Hi, thanks for coming. This is Juyong John from Handong University, South Korea, and I will be having a talk about our study on the threats to validity in evaluating mutation-based fault localization techniques. This is a co-work with Shin Hong of Handong University. The DefEx4J benchmark gives great chances to evaluate the testing and debugging techniques reliably by providing unmodified real-world bug cases. The unmodified bug artifacts gathered from an open-source project allows researchers to conduct the experiment in a more fair manner by making the quantitative analysis between the testing techniques possible. So it helps to manage the external validity threats by providing a large real-world bug corpus. One of the results with DefEx4J is to quantitatively compare the fault localization techniques, including 5 SBFL and 2 MBFL techniques. The result of the experiment implies that the MBFL techniques do not perform well for faults in DefEx4J, which was contradictory to the study results of the MBFL techniques. The original study showed the quantitative results which do not explain the limitations of MBFL. So, to identify the limitations of MBFL and find the chance to improve the MBFL techniques, we have revisited the same experiment, rather focusing on the qualitative analysis to look at the details of the evaluation. We have found that when evaluating the MBFL techniques, the configuration of the experiment setup largely affects the result of the evaluation, which was not explored in the original study. In this study, we have suggested the configuration factors that matter to the experiment results. We will be showing what those factors are and how they matter when experimenting the MBFL technique. We revisited all of 26 JFree chart artifacts in DefEx4J by using different configuration and saw how the results changed. To do so, we removed some noises in DefEx4J bug artifacts and used as much resource as we can with an assumption that the best effort debugger is localizing faults in an optimized condition. We saw that the result of the experiment changed sensitively by the configuration. Among the 26 artifacts, the comparison result of fault localization techniques changed in 19 bug artifacts, and in 9 artifacts, the best performing technique changed. The result also showed that the bug rank of MBFL increased dramatically compared to that of SBFL. In the next slides, we will be dealing with what the configurations are in more details. We removed the noises in data in two ways. First, we clarified the buggy line and the failing test cases by selecting a single bug for artifacts with multiple bugs. Although DefEx4J assumed that all change lines that are commit contribute to all failures, the commit may concern multiple bugs that result failures in different test cases. So we defined the buggy line as the location of the selected bug and removed the failing test cases that fail by the other bugs. Secondly, we filtered the flaky test cases by removing the two artifacts that do not reproduce the specified failure. Best effort debugger uses as much mutant execution information as possible. So we first used all possible mutation operator given by the major mutation tool. Then we chose as many possible passing test cases to be used for fault localization. The passing test cases we used are the test cases that cover at least one line executed by a failing test case. Meanwhile, passing test cases were arbitrarily selected in the previous study. Another assumption of best effort debugger is trying as much suspicion with the failing test cases as possible. So we also purified the failing test cases to observe the changes of test results by mutation. For failing test cases, we removed the lines that are relevant to the failure and made each failing test case to have only one assertion. Finally, we excluded the safe lines from the ranking by assigning lowest suspiciousness score to the lines that are not executed by any of the failing test cases. This was done because the MBFL techniques may assign negative suspiciousness score to the suspicious lines. The table showed the 8 artifacts that the rank of MBFL technique changed significantly. The major configuration that changed the result of the experiment were using more mutation operator, excluding safe lines, test purification, and removing irrelevant test cases. To recap the talk, in our study we have shown various factors that matter largely on the MBFL evaluation results, so this needs to be carefully managed in the MBFL experiments. There needs to be more qualitative analysis on the DefEx4J artifacts for improvement of the benchmark, and for different applications, the DefEx4J artifacts should be revised and extended. This is the end of the talk. Thank you for your attention.